Alright, so let's finish up the review. When you see a problem like 23 where it mentions average value, you need to remember the formula for average value, which is always 1 over b minus a, b and a meaning the endpoints. So for this one it would be 1 over 2 minus 0, and then the integral from 0 to 2 of the function given. Okay, so this is going to be 1/2, okay, and then we're going to do the integral. Okay, so if we bump the power up by 1, we get 4, so 1/4 x to the 4th plus 1/2 x squared, and then evaluated from 0 to 2. So basically you just have this fraction hanging out to the front, okay, that's going to get multiplied. So you're going to have 1/2 times what you get when you plug in 2 times what you get when you plug in 0, but with 0, remember, you might be able to just notice, hey, if I plug in 0 and 0, I'm just going to get 0. And so in the end, you get 3. So the average value between 0 and 2 of this function is 3. All right, so let's look at a couple more average problems. So 24, find the average value of the function over this interval from 0 to 3. So again, the average value formula is 1 over end minus beginning of the integral. Notice these numbers are always the same, okay, of your function. And the function, I'm going to rewrite it, is actually x squared plus 16 to the negative 1/2 times x dx. Okay, it's negative because it's in the bottom. It's 1/2 because it's a square root. Okay, so I'm going to go ahead and write it like that because it'll make it easier for us. So this is certainly a u substitution problem because I have 2 parts. So I'm going to make this x squared plus 16. So the derivative of that would be 2x dx. So notice I have u to the negative 1/2 here, but I don't have a match here, so I need to multiply by 1/2 du. And then I need to change again the upper and the lower limits. So the new upper limit would be 3 squared plus 16, or 25. The new lower limit would be 0 squared plus 16, or 16. So here's what you have. 1/3 times the integral from 16 to 25 of 1/2 u to the negative 1/2 du. So the constant stays. We add 1 to the power. Remember, negative 1/2 plus 1 is 1/2. So it's 1 over new power, u to the new power. Okay, and then evaluated from 16 to 25. And don't forget, technically, you also have the 1/3 here. Like this 1/3 isn't going away. So this is going to cancel. It's going to be a 1/2 times 2. That's just 1. So this is going to be 1/3 times 25 to the 1/2 minus 16 to the 1/2. But 1/2 power just means square root. Okay, so it's going to be 1/3 times parentheses 5 minus 4, or just 1/3. Okay, so the average value in this case over the interval from 0 to 3 is just 1/3. Alright, so let's do an application problem. I would probably be more likely to put an application problem on the test than I would be these two, just FYI. Alright, so the average value, this one we're going from 0 to 4 hours, so it's 1 over 4 minus 0, the integral from 0 to 4. And again, I'm going to separate these. 1 over t squared plus 1 times 0.2 t dt. So again, 2 parts means substitution. So u is going to be t squared plus 1. du is going to be 2t dt. Okay, so you can think about this in a couple of different ways. Okay, one is this is 1 over u. This doesn't match this, but notice it's like almost right. It's just there's a decimal point there. So really we just need to divide by 10. Think about if you divided 2 by 10, you'd get 0.2. Okay, so this is what I've got so far, although I do need to change the limits. So I'm not going to put the limits in just yet, but I've got 1 over 10 times 1 over u du. Okay, but I still need to change the upper and the lower limits. So the upper limit's going to be 4 squared plus 1, or 17. The new lower limit is going to be 0 squared plus 1, or 1. So if I move the 1/10 and combine it with the 1/4, I get 1/40. And then the derivative of antiderivative of 1 over u is ln. And then evaluate that from 1 to 17. So you end up getting 1 over 40th, and then ln of 17 minus ln of 1. So the shorthand is, this is 0. The natural log of 1 is just 0. So you end up just getting the natural log of 17 over 40. But for this problem, it probably makes sense to go ahead and put it in a decimal form. So it would be 0.071 milligrams per centimeters cubed per hour. Okay, now the measurement, you just need to read the problem. Notice the concentration is milligrams per centimeter cubed, and so because we're doing an average rate per hour, that's why we added the per hour there. All right, so starting with 26, remember what I said, I will give you the formulas that you need. Okay, so if there's a economics formula problem, just assume that I'm going to give that to you. Okay, you're still going to have to know how to use it though. All right, so for 26, okay, the total income in the first 5 years is going to be the integral from 0 to 5 of the original amount, which was 500, e to the 0.08t. Actually, this one really isn't necessarily requiring the formula. You're just noticing that that's a rate, and I want to go back and find the total income. So not to beat a dead horse, but this is another u substitution problem. So the derivative is going to be 0.08 dt. So let's write what I have. I'm going to move the 500 to the front. I don't know what my upper and lower limits are going to change to, so I'm just going to leave those blank. Okay, and then I have 1 over 0.08 because I don't want that to be put in this problem. Okay, it's not part of it. And then e to the u du. So now I just need to find the new upper and lowers. Okay, so it's going to be u equals 0.08 times 5. So that's going to be 0.4. The new lower is going to be the same as the original. So this is going to be 0 to 0.4. So move the 1 over out here, and if you divide 500 by, or multiply 500 times 1 over 0.08, you're going to get 6,250. And then the antiderivative of e is just itself. So it's going to be e to the u evaluated from 0 to 0.4. So this is going to be 6,250 times e to the 0.4 minus e to the 0. Okay, be careful of just assuming that it's always 0 when you plug in 0, because in this case it's not. E to the 0 is actually 1. So if you plug this in your calculator, you're going to get about $3,073.90. Okay, so if you have the rate, if you have the derivative and you want to go back to the original, use antiderivative. Okay, number 27. Starting at age 28, you deposit $2,500 a year into an IRA. Treat the yearly deposits as continuous income stream. And so this is going to be one of the formulas that we talked about in the economics section. And so the formula for future value, remember, is e to the rate times time period. So pay attention. If you're 28 and you're going to retire when you're 65, that's 37 years, right? So that's an odd year number, but That's what you have. And then it's the integral from 0 to whatever that number was. These two always match. And then it's 2500 e to the negative rate times time power. Okay, so I'm going to clean all of this up. I'm going to move all the constants to the front. This is 2500 e to the 1.295 power here. Okay, but then I still am going to need to clean up this exponent. It's not just plain old t, so I do need to use substitution. Okay, so let's talk about what I have, right? If you want to label this, here I have e to the u. Okay, I already moved this out to the front. But here, I'm not even trying to have any number, and I have this negative number that I don't want. So I'm going to do 1 over that. Okay, I just can't stress enough how often you're going to do this step. You're going to just have to get rid of a number by doing 1 over that number. And then we're going to have new upper and lower limits. So the new upper limit is going to be negative 0.035 times 37. So that's going to be negative 1.295. And the new lower limit is going to be negative 0.035 times 0, or just 0. So as weird as it is, this is what we have. The integral from 0 to negative 1.295. And then we have 1 over negative 0.035 e to the u du. Okay, so this can pull out to the front. So this would be 25,000 e to the 1.295 over negative 0.035. And then it's going to be e to the u, because the antiderivative of e is just e, and then 0 to negative 1.295. So, as strange as this is, just let your calculator do the weirdness. So this is going to be your constant, and then you're going to have e to the top power minus e to the bottom power. Okay, and if you work that out, you get 189,356.86. Let me read this problem. It says, how much of this is interest? Okay, so this is one of the things I asked for. So how much of this is interest? Well, for that, you're going to have to figure out how much they're actually putting in. Okay, so this is going to include interest. So if you take the 189,356.86, remember, they're putting in $2,500 each year for 37 years. Okay, so this is actually the money they're putting in, so it doesn't include, it's not included in the interest. It's part of their money, but they won't include it in the interest. And so it's 96,856.86. So think of it like they only contributed this amount, right? But they ended up having this amount, the difference being interest. Okay, that's how investments work, right? That's why people can retire early and all that good stuff. All right, 28 is another future value problem. So for 28, though, the interesting part is that we don't have a clear revenue amount or a true income stream. We have an equation for that. So when we go to do future value, okay, the time period I think this time is 5. So it's going to be e to the rate times time period power, and then the integral from 0 to 5. And this is where you're going to put in the income stream. Okay, notice it is not actually a dollar amount this time. Okay, and then times e to the negative 0.0275 t power dt. So yes, I know that's weird, but we can actually combine these e terms. Okay, we can combine them by just adding the exponents. We're allowed to do that. So this is going to be e to the 0.1375 power. That's what you get when you do these two times each other. And then the integral from 0 to 5. We are still going to have the 1850, but then these can be combined just by adding those up. Okay, and if you add those up, you get negative 0.0475 t. Don't forget your dt. Okay, so you're going to notice these are going to work very similarly. Like once you do a few of these, you're going to notice, hey, I'm always kind of getting rid of the decimal I don't want by doing 1 over that decimal. All right, so I'm going to move the 1850 to the front. I still got my E thing out to the front. Okay, I don't want this number, so I'm going to leave these integral symbols alone, but I want 1 over that number to get rid of it. And then I've got e to the u du. Okay, so upper and lower. So all you're going to do is plug in 5 here, plug in 0 here. So lower, you're going to get 0. Upper, if you plug 5 in here, you're going to get negative 0.2375. So again, as ugly as it might look, you've got this weird, complicated constant out to the front. And I forgot to put my limits. This is 0 and negative 0.2375. Okay, so I move that out to the front. The antiderivative of e is just e, evaluated from 0 to negative 0.2375. And then notice, like from a point, this is the same as the one we just did. So the constant, again, stays out to the front. And we just have e to the negative 0.2375 minus e to the 0. Okay, so I want to make sure that you can actually punch this in your calculator. So 1850 times e raised to the 0.1375 power, and then get out of the exponent and then divide by negative 0.0475. And then times parentheses e raised to the power of negative 0.2375 minus e to the 0. Notice I'm not cleaning up anything. I'm just punching it in just like it says. Okay, and then I'll get the answer that's on the key, which we round to the nearest penny. So it's about 9,447.24. Okay, so 28, find the future value. I just did 28. It's been a long day. 29, the demand function for a certain make of, notice I really did future value problems. Present values are the same as future values, except we don't include part of the equation. Okay, so if you have a present value, you should be able to do those two. They work much in the same way. All right, so the demand function is d of x equals negative 0.01x squared minus 0.1x plus 6. Okay, I promise you, you will have to do something like this on the test, so you need to really make sure you pay attention to this one. All right, so the first thing is where p is the price and x is the quantity. Okay, so they're telling you what the price is. The price is 4. Okay, so that's part of what you need for the equation. But the rest of it is you need to know what x is. Okay, so we're going to set this equal to 4. We're going to move this 4 over. So we've got negative 0.01x squared minus 0.1x plus 2 equals 0. Okay, I don't know about you, but I'm not going to factor it looking like that. Okay, and I don't think you should try either. So if you need to move it 2 decimal places, multiply by 100. If you need to multiply it or move 1 decimal place, you multiply by 10. So I'm going to multiply by negative 100 because that's going to not only get rid of the decimal for me, but it's going to give me nice, pleasant, fuzzy, warm numbers. Okay, because I know how to factor this. I feel confident with this. This is x plus 20. This is x minus 10. So I end up getting negative 20 and 10, but this is the quantity of items, right? So this one doesn't make any sense. So x equals 10. So now I'm trying to find consumer surplus. So this is what consumer surplus looks like. 0 to whatever you get for your x, the integral of the function you were given, dx, and then minus 4 times 10. In other words, we're just going to minus the 40 off the end there. All right, so let's make sure we can do this. So pull down the constant, bump the power up by 1, multiply by 1 over the new power. So that's the same as saying this number times 1/3. Okay, I'm just combining them together. This is going to be 0.1 over 2 x squared plus 6x evaluated from 0 to 10. And then once we're done, subtract 40 off. So give yourself some room, but I need this entire equation. So this is looking like this. Okay, so that's when we plug in 10. Notice if we plug in 0, we're going to get 0. And then minus 40. So just like I showed you before, let your calculator do this. This comes out to be 11.6 with a bar. If you read through the problem, it was in thousands to begin with. So the answer for consumer surplus is $11,666.67. That last digit gets bumped up because the numbers after it are 6, larger than 5. All right, find the producer's surplus. Okay, so that formula is a little different. So here's the supply equation. Remember, producers control supply, consumers control demand. All right, so again, we were given that the price is 20. So just like the last one, we just need to figure out what x is. Okay, so this one's a little different. We're going to subtract 2 on both sides. We get 0.0002 x squared equals 18. So if we divide by 0.0002, we're going to get x squared equals 90,000. Okay, well, we can take the square root of that and we come up with something pleasant. It's 300. So now that we have our x and our p, we can do producer surplus. The difference between producer surplus is these numbers are out to the front. So it's 0 to 300 of the equation you were given. I forgot the 2. So it's 2 plus 0.0002 x squared dx. Okay, so this is going to be 6,000. Okay, and then let's go ahead and just do the derivative. So this is going to be 2x plus 0.0002 over 3x cubed, evaluated from 0 to 300. Okay, so we're going to plug in 300. Minus the big fat 0. 0 and 0 would just give you 0. And so if you do all of that, you get 3,600. All right, so last one like this, and then we'll get to partial derivatives. All right, so when the problem is in equilibrium, you aren't given the price or the quantity. Okay, you have to figure those out first. Okay, but equilibrium means equal. Okay, so you're going to set the demand equation equal to the supply equation and then see what you can do from there. Okay, so you would move terms over. So if you did that, you're going to get 0.2 x squared plus 3x minus 20. Okay. In other words, like add x 0.1 x squared, add x, subtract 40. So notice, I don't want this here. So you can multiply by 10, but then that's still a 2. That's not a problem, okay? But it would actually be better if you would just multiply by 5. The point is, if you can get this to be 1, then why not? It makes for very easy factoring. Okay, so I really like that to be 1. It makes my job with factoring much, much nicer. So you'll get x plus 20, x minus 5. So x can't be negative. So that means x must be 5. Okay, but notice we weren't given price either, so now you need to go back and find price, and it doesn't matter which equation you use. So I'm going to use the second one, 0.15 squared plus 2 times 5 plus 20. If you plug that in, you get 3250. All right, so let's start with consumer surplus. Consumer surplus, remember, looks like this. It's the integral from 0 to x of the demand equation, so make sure you pull the right one, but the demand equation is this one. And then minus price times quantity. So I'm going to go kind of quickly through this because we've already done one like this. This is just putting them both together. So take the antiderivative, bump the powers up by 1. All of this is going to get evaluated from 0 to 5. This is going to be 162.50. Okay, so I'm going to let you just write that out, but if you plug in 5 and then subtract 0 and then make sure you subtract this off, you're going to get 20.83, where the 3 repeats and it's hundreds. If you read the problem, it's hundreds. So that means consumer surplus is 2,083.33. Okay, move the decimal place twice for hundreds, 3 times for thousands, twice for hundreds. So when you transition to producer surplus, remember that the 162.50 goes in the front. You still go from 0 to 5, but you switch equations. You switch it to the supply equation. So this is going to be 162.50 minus 0.1 over 3x cubed plus 2 over 2x squared plus 20x, evaluated from 0 to 5. So again, I'm going to let you practice with that, okay? But it would be 33.33 hundredths. So the producer surplus is $3,333.33. Okay. Okay, so last but not least is partial derivatives. Okay, if you'll keep in mind what you're doing, in other words, you're taking the derivative with respect to one variable and you're treating the other as a constant, it will be a whole lot easier. Okay, so first I'm asking you to find the partial derivative with respect to x if the 2 variable equation looks like this. Okay, so the partial derivative with respect to x, that means treat x normally, treat y as a constant. So the derivative of 7x is still 7. The derivative of 8y, it's a constant all by itself, so that's going to be 0. The derivative of 2 is also 0, so you just get 7. Okay, part B, find the partial derivative with respect to y if the equation looks like 3x squared plus 2xy minus 7y squared. So we're going to treat y normally, treat x as a constant. So the derivative with respect to y is going to be 0 because x is a constant. That's full constant. Okay. Here we're going to treat 2 and x as the constants they are, and we're going to multiply by the derivative of y, which is 1. And then the derivative of this is 14y. So in the end, we get 2x minus 14y. And then lastly for this one, this is just different notation. So dz dy, if z is 4x squared y minus 5xy squared. Okay, so this is just telling you to take the derivative with respect to y. So you could also say z prime if you want. Okay, so I'm going to write that. So treat 4 and x's as constants. The derivative of y is just 1. Treat 5 and x as constants. The derivative of y is 2y. Okay, so notice when you have mixture terms like this, like where there's an x and a y both in a term, you just pull down the constant pieces and then you find the other derivative as normal. So this would just be 4x squared minus 10xy. Okay, I promise if you practice a few of these, they're not quite as bad as you might think. All right, so for 33a, I'm asking you to plug in numbers. So not only do we need to find the derivative with respect to x, but then once we do, we need to plug in 4 and 1. So first let's find the derivative with respect to x. So we have mixture terms here, right? So we're going to treat the y's as constant. So pull the y part down. And then we're going to treat x squared like we normally would, and the derivative of that is 2x. Okay, here we have mixture terms, so we're going to pull down the parts that are constants and then treat the x part as we normally would. So we end up getting 2xy squared minus 5y squared. So then if we want to plug in 4 and 1, remember it goes alphabetical order, so x is first. 2 times 4 times 1 squared minus 5 times 1 squared. So 8 minus 5 would end up being 3. All right, so the derivative with respect to y, and then we're going to plug in 2 and 4. X to the 4th ln of y. Okay, so we're treating y as a constant. We're taking the derivative, we're treating x as a constant. We're taking the derivative with respect to y. So first let's find the derivative with respect to y. So x gets pulled down. This is a combo term, right? So the constant gets pulled down. And then I treat y as what I'm taking the derivative of. The derivative of ln of y is just 1 over y. So I end up getting x to the 4th over y. So then if I want to plug in 2 and 4, it will be 2 to the 4th over 4, which is just 4. 16 over 4 is just 4. All right, so one more derivative with respect to x. This one requires chain rule. So if I want the derivative with respect to x, I would do outside. So it's 5, move the power to the front, keep the inside the same, and then reduce the power by 1. But then I also have to do times the derivative of the inside, but it's with respect to x. Okay, so what's the derivative of x squared with respect to x? 2x. What's the derivative of y squared with respect to x? Remember, y is a constant, so that's just going to be 0. So you end up just getting 10x and then x squared plus y squared to the 4th. And so now let's just plug them in. So it's 10 times 3 and then 3 squared plus 5 squared to the 4th. So just let your calculator do this. This is a very large number. So I think it's 40,090,080. Okay, it's so large because you have the 4th power and this is a big number already. All right, so just remember, partial derivatives are where we treat one variable normally and we treat the other as a constant. Okay, so 3 more problems to go. All right, so 34. So we have t of v comma x. Okay, so this is volume of the air, or the air pressure, and then the depth of the dive. So I've got this right here as my original function. Okay, so I'm going to rewrite this as 33V times x plus 33 to the -1 power. I'm going to do that so I don't have to do quotient rule. Okay, I can just do product rule instead. So first, let's find the derivative with respect to x. Okay, so remember, it'll be a good kind of practice of this anyway. So we're going to treat v as a constant. So this 33v can just pull down. Okay, and then I can just take this derivative, right? So I can multiply by -1, bring that power around, x plus 33 to the -2 power, and then times the derivative of the inside, which is 1. So cleaned up, this is just -33v over x plus 33 squared. And then now we're just going to plug it in. So the derivative with respect to x, the partial derivative, with 70 and 17 is -33 times 70. Okay, the volume comes first in this problem. And then 17 plus 33 parentheses squared on the bottom. So this comes out to be -0.924 minutes per feet increase in depth. Okay. Remember, if you read the problem, I didn't say this at the beginning, but T represents time. So how much time you have left on your tank depends on two things. The volume of your of the air in your tank, okay, like in other words, how much air you have left versus how deep you go, okay, because it uses it at different rates. All right, so if you look at the key on this one, this means that the time of the dive goes down, okay, for every foot you go deeper, okay, when your volume of your tank is remaining the same. Okay, that's what that means. Okay, 35. So this is a maximizing profit question. So we have two types of products, X and Y. And here is our profit equation that involves them both. So you're asked to find the derivative with respect to x, and then we're going to plug in 1 and 3 and then talk about what that means. Okay, so treat x normally, treat y as a constant. So this is going to be the derivative of -4x squared is just -8x. Okay, the derivative of this, if there's a combo, you pull down the constant, you multiply by the derivative of x, which is just 1. But this is not a combo. This is all constant, so it's just 0. The derivative of this is 4. This is all constant, so its derivative is 0. That's a constant, so its derivative is 0. So you end up getting -8x plus 4y plus 4. And so now let's plug in the numbers they mentioned. I think they said 1, 3. So it's going to be -8 times 1 plus 4 times 3 plus 4. So if you read the problem, I think it's in thousands. So it's 8,000. Okay, so it's on the key, but in other words, the profit is increasing. It's increasing because it's positive by 8,000, okay, per month when, hang on a second. Yeah, the profit is in thousands, but the product number is in hundreds. Okay, so the profit increases by 8,000 per month when 100 more units of A are made, because we're changing A, and Y, or the second product, remains the same. Okay, so product B is not changing, product A is changing. Okay, so for every 100, and that's only because the problem's in hundreds, we change in product A, we're going to make $8,000 more. Okay, last but not least, if I give you a problem like this, I will give you kind of which partial derivative you're supposed to be finding. And if I ask you also to tell me whether it's complementary or competitive, I'll give you that formula too. I am struggling on this last question. Just to write it down, apparently. All right. So make sure I've got my P's and Q's there. All right, so the first one is you need to find the derivative with respect to the second item of the first equation. So derivative with respect to Q, treat P as a constant. So constant, derivative is 0. That's a full constant, its derivative is 0. That is what I need to treat normally, so this would be 0.006 Q. Okay, so I just get negative 0.006 Q. Okay, notice this is negative. And then I need to find the derivative with respect to the first item in the second equation. Okay, so remember what that means. P will be treated as normal, Q will be treated as a constant. So this is a constant, derivative 0. This one's the one I'm going to treat normally, negative 0.008 P. This one is a full constant, so it's going to be 0 when I take its derivative. So 0.008 P is what I get here. Notice this is also negative. And when they are both negative, the products are complementary. Okay. So that's it. I know that's a lot of questions on the review. Just remember, like I always tell you, the review is longer and supposed to be more challenging than the test itself will be. Okay, so keep that in mind. That's the point of the review, to get you really rigorously prepared for the test so that when you take the test, you're like, oh, that wasn't so bad at all. Okay, that's really the point. So study hard.